Question 8, and this is about circles. We're given the circle's centre and a point that it passes through. I recommend a diagram, so sketch a circle, mark on the centre, and then put point P anywhere on the circle, but it makes sense, given the numbers of the coordinates, to put it up to the top right. So in order to write down the equation of a circle, you need the centre, which we've got, and you need the length of the radius, which we haven't got, but we can work it out. So just use the distance formula on those 2 points. We've already used it several times in this paper. Simplify it down and we get the square root of 29. So the equation of the circle is x minus 3 all squared plus y minus 1 all squared equals 29. Now part B requires us to think about a tangent to C at P. Right, add this to the diagram because it helps you to think about what we need. So I've drawn the tangent on. I've also drawn the radius on and noted that the angle between the radius and the tangent will be a right angle. We need that fact. So, what do we need to write down the equation of the tangent? We need a point that the line passes through. Well, we've got that, that's P. And we need its gradient, which we don't have yet. But we can work out the gradient of the radius. So let's do that first. Difference between the y coordinates of those 2 points. Subtract the difference between the x coordinates of those 2 points. Divided by. That gives us 2/5. And therefore we can use the fact that the negative reciprocal of that will give us the gradient of the tangent. And then we have a point that the line passes through, and we have a gradient, so use y minus y1, etc. Substitute in, and then it's just an algebra exercise to rearrange it into the form that the question requires. And there's a few ways of doing that, but this is my way. And that's our answer.